Hello everyone. Today we are here for grade 8 science, force in action chapter, unit 9, but the topic is 9.1, the idea of density. Now before we go for the density, what it is and how to calculate, I'd like to ask you something. Whenever you measure, for example, if you are measuring a kg of feather and a kg of a brick or iron, whatever, which one do you think will be greater? Obviously both of them are 1 kg each, so both of them will be equal in weight. But when you compare, one feather would be large, there would be a space taken up by it would be more, but whereas brick, since it is squashed up, it would be a bit smaller in size, but still kgs will be equal. So now whenever we see brick and these feather cases, feather, since it is occupying more space because it is lighter in weight and also it is expanded, still the other object, brick, may be same kg, weight may be same, but still it's squashed up. So whenever we measure density or whenever we talk about density, this whole thing also comes in mind. Now same thing has been explained in their book also, taking up of the spaces by the matter. Now whenever we talk about density, for example, this paper, if you see, it's very thin. And again, if you check this duster, it's a bit thicker. So by the thickness also you will come to identify or find out whether the object has more density or not. If object is thinner, it will be having lesser density. If object is thicker, it will be having more density. So basically density, whenever we talk, it is in a cubic meter. For example, in this particular object, in 1 cubic meter or in 1 cubic centimeter, how much matter or how much mass of that object it is containing, that is what we call it density. So by the word density we denote with capital D. By this explanation you understand mass per unit volume. In 1 cubic meter or in 1 cubic centimeter means volume, because SI unit of volume is centimeter cube. So in 1 particular centimeter cube, how much mass of matter it contains? For example, mass we usually calculate in kg. So this will give you density of that particular object. That's why density formula we have D is equal to m by V. Now density of water is fixed. If you see, density of water in gram centimeter cube, if we calculate it, it is 1 gram per centimeter cube. It means in 1 cubic centimeter it contains 1 gram of water. If whenever you are calculating any kind of sum, sometimes they will not give you volume of water, or sometimes mass will not be given but density will be given, or sometimes density of water also will not be explained. At that time you have to remember density of water in gram per centimeter cube is 1 value. This is fixed. So before we go for calculation, few things you have to remember. What is this M and V? Just now I have explained it to you. M stands for mass and V stands for volume. Now how do we calculate mass? Mass of any object, mass is basically in this particular object how much matter, quantity of matter contained in it. So usually we calculate it in terms of kg. So by that you can understand somehow weight. But remember, mass and weight are not same thing. They are different thing, but still here in one planet whenever we are talking, its mass we calculate in kg, its weight basically equal, but they are not same thing, remember. Now for mass you can use weighing scale also, or by balance also you can use it and find out how much kg it is or gram it is. You can measure in gram also, you can measure in kg also, anything. And whereas volume, whenever we say it for fixed object, we know how to calculate it. You have learned in mathematics also in grade 7. Suppose an object is cube, for example, it's a brick. Let us take example. This is length, this is breadth, you know that this is height. Then if you want to calculate its volume, then it is L into B into h, because volume of cuboid is L into B into h for regular objects. Sometimes object may not be regular, it might be irregular. Now what do you mean by irregular and all? Certain object like cube, cuboid, or may it be cone, or may it be cylinder, whatever, whose values or formula or its volume can be calculated using formulas and all. Now sometimes object may be irregular, shape may not be exactly, like 3D shape, or in that case we may use some other method of calculating its volume also. Right now here in the video, one picture I am displaying it here. You can see there in a container water is there, measuring cylinder it is. Suppose this container, it's a measuring cylinder, it's water, I have put it till 50 ml. Now in that particular container, you have put an irregular object whose volume you don't know. Now while putting it, you can see the changes. This was 50 ml in the beginning, but when you kept it, the water level has rise to 60 ml. That means what is the difference between previous and now? 10 ml. So through that means that a particular irregular object volume is 10 ml. And that 10 ml you can convert it to centimeter cube. How do we convert? Remember, 1 centimeter cube is equal to 1 milliliter. If suppose this is a water, I am drinking a water, in this bottle it contains 50 ml of water. This means it is containing 50 centimeter cube of water whenever we convert it into different SI unit as well. So by this concept also sometimes in the question comes up, conversion of centimeter cube to milliliter or milliliter to centimeter cube. This is how we do. Remember this, 1 centimeter cube is 1 milliliter. Right now in the video, one particular image has been shared. You can see there various objects which you have learned in chemistry. In our previous video, we have learned about various elements like aluminium, magnesium, zinc and all, iron and all. That those elements density has been fixed. These are fixed. So that's why that I have shared it. You can even check that and understand. Certain object or elements, their densities are fixed in nature. So sometimes in question, if the value is not given for density, you can even utilize it. Now since I'm talking about question, how the question comes. For example, if it is said, if a density suppose, now whenever we are talking about question, so how the question comes. For example, it is written here, find the density of an object of mass 2 kg and with a volume of 30 meter cube. Now 20 kg is a number and another 30 meter cube is given. So when you write it, by the word kg means mass. So mass of that object m is equal to 20 kg. Another given is 30 meter cube, that means a volume. So volume of that object V is equal to 30. Now I have just shared you a formula, density. Your question is find the density. So D is equal to M by V. Now in place of M you'll put 20, in place of V you'll put 30 kg per meter cube. Why I am dividing per? Because volume is in the denominator, it's being divided. So these are the SI unit. Its SI unit also will be dividing it. So since SI unit of mass is kg, I have written kg on the top. SI unit of volume is meter cube, that's why I have written meter cube in the down. Now you cut it down, 0.66. That means it is 0.66 kg per meter cube for this particular question. Now in the same question, sometimes they will change it. They will already give you density and they will ask you mass. Means out of 3 given values, 2 might be given. They might give you D and V, they will ask you to find mass. They might give you M and D and they will ask you to find volume. Same formula only, use it, but you put the values differently. For example, what I mean to say, if your question in this particular is given, find the mass of an object with density 20 kg per meter cube Suppose your question is like this. Find the mass of an object with density this much, 20 kg per meter cube, and volume 10 meter cube. Now here density and volume is given. They are asking you to find mass. Now same formula if you use. D is equal to M by V. You are supposed to find mass. Let the M be there. Now in our maths video I have already explained it to you about is equal to and how the values and sign changes. Now here V is dividing. You are sending it to the other side to find the mass. So while going there, division will be converted to multiplication. So it will be into V. That means formula for mass is density into volume. So density it's clearly given 20. Volume it's clearly given 10. Now SI unit of mass is kg, you know that. So it should be kg. 20 into 10 to 100 kg is your mass. Now similarly sometimes the same thing, other thing will be changed. So they will be giving you D and M, but they will be asking you V. Same thing. Similarly you will apply and then find out the formula. So now regarding this particular formula, some questions are given in end of unit review. Please go through it and try to complete all the questions as well. So after completing the density, what do we have a new topic? We have pressure. So density concept is explained till 9.3. Its calculation and concept of it, everything has been over. Now we are in 9.4 pressure. Now before we go to pressure, I want to show you some example. Right now in this video you can see one picture where a person hand is there and a nail is there and we're using a hammer, he is trying to hit it. And in the second line there is again another, he has reversed it. Nail, one is pointed, another is flat. So in the pointed one again he is hitting. So when you do that, please try to analyze and observe what would be the difference. Now in the pointed side, since it is in the wall, when you are applying force, hammer gives the force. So when you are applying it, that particular pointed part of the nail will apply a pressure in the wall and then it will start penetrating inside. But whereas in the second picture, there is like the other part of the nail is reversed. So that part when you are hitting, it will not try to enter inside the wall. Why? Because of the area. Now if you see pointed one has least surface area and the other one is little bit flat. So pressure is in a certain unit area, how much force you are applying it. That is what we call it pressure. For example, let me ask you a few questions regarding pressure. Whenever you are in a desert area, if you are wearing a pointed heel, would you be able to walk properly? No, obviously. Why? Because the shoe heel will be containing downside a little bit pointed. So pointed means less area. So when you are walking, you will be giving more force in the ground. So you will be able to penetrate inside. So that means you are applying more pressure in the ground. So since it's a desert, your particular shoe will be penetrated inside. Now similarly, same case in the desert area if you wear the flat shoe. Now flat shoe has more area. So since its area is more, it will give less pressure. So you can walk easily. That's why you have seen camel foot, since it keeps on walking in the desert area, its foot has been adapted in such a way it's a little bit flat. or sometimes when we walk in desert area, we always use similar case, flat shoe only. Even in the snowy area also where there is snow, same cases only. Now why do we do that? Because for pressure we have one relation. Relation of P is F by A. F means force, A means area. You have learned about the force in previous class also. So since that hitting case also, whenever we are hitting, that means we are applying force. And force SI unit is Newton, remember. So while, for example, this is a wall, this is a nail, when I am hitting it, that means I am applying force of 20 Newton. This N is SI unit of force. Remember this. The way SI unit of mass is kg, similarly for force it is Newton N, capital. And area, A stands for area. Now you know that area of any figure we always calculate in square of centimeter or meter, whatever. So for example, if it is taking 30 meters square area and we want to calculate how much pressure it is taking, then we have formula P is F by A. In place of F will keep 20 and A 30, and you cut it 0.66. Now SI unit, basically F SI unit is N by meter square. Now since N by meter square is a bit bigger, it has another particular SI unit given for pressure, we call it Pascal, PA. So 0.66 PA. Basically Pascal is Newton per meter square only, but in short we write PA. This Pascal is given for the behind the name of the Blaise Pascal. He has worked in these all areas more, so that's why under his name, to honor him, it's given Pascal PA in short. Now that is the concept, whatever we are explaining right now is the concept of high pressure and low pressure. Similarly, high pressure is the one we talked about, wearing a heel and walking in the desert, you are giving more pressure, it's high pressure. Low pressure, you are walking using the flat shoe, pressure would be lesser. So sometimes whenever we wear a bag, usually school bag, if you check, their strip out here is a little bit broadened, area is more. Why? Same case. Since its area is more, pressure would be less because they have a relation. Area and pressure are inversely proportional. Inversely proportional means when the unit is in the down. So this means if area is more, pressure would have to be less. If area is less, pressure has to be more. So that explains you about low pressure and high pressure. Now pressure in liquid. So in your book there is a concept given about the diver. So diver, whenever they dive in down the ocean, the more they go deeper, more amount of pressure the water will be applying in that diver. So you will be carrying with more pressure downward. Now right now one picture is explained in there. One bottle is there and you can see hole has been drilled out there. On the top one water is flowing. Suppose your picture is like this. Water is there. Hole here, here, here. So from here water is flowing with less pressure. The more it goes down, it's flowing with more pressure. So this explains that in a liquid, the more it goes deeper, its pressure increases. Now when we talk about our last topic is pressure in gas or air. Similar cases, the place where we are staying in the earth, there is an atmosphere, air, layer of air. So in the sea level, air will be giving the more pressure. So in the sea level, its pressure would be highest. Another reason why, because the density, the more you go up higher, the density or the thickness of air will be lesser. And the more you go downward, its thickness will be increasing. That's why in the sea level, you'll be having higher pressure of the air. And that one, the pressure of air, whenever we compare, we call it atmospheric pressure. And we denote it with, we call it atmospheric pressure. And in short, ATM dot pressure. From here also you can understand it is talking about atmospheric pressure. Now, one example I would like to show it to you, how the pressure has been explained. See, this is normal bottle of water. Whenever we press it, highest press I can do till here only. Why? because cap is tight. So whenever I open the cap and squeeze it, I can press till down. That means inside the bottle there is air. So whenever air is there, air has to apply pressure, the way in the first picture while hammer was the nail was applying pressure in the wall. Similarly, air also applies pressure. At that time it is forced to go outside. Right now in this particular video I am sharing you four images. In the first one you can see a bottle where on the top egg is kept. In the second one it is burnt, the pepper, and then it is dropped inside the bottle, and on the top of it egg has been kept. And in the third image you can see that slowly egg is being squeezing inside when the fire is getting extinguished. And in the fourth, completely the egg has been squeezed down inside and it has started to break. Now what does this mean? This is showing that since in the second bottle completely fire has been extinguished, there is the air, whatever from the outside, is giving it pressure to get it down inside. So that's why that egg is getting down and getting squeezed. So from here you can understand even air also applies pressure, and that pressure we even call it in the earth scenario atmospheric pressure, and we can even calculate in other scenarios as well. So this much for today. We have completed till pressure topic. Next again there are two more topic in here. So that we'll be doing in second video. So try to complete all the end of unit review regarding this all topic questions, and if there is any doubt you can always call or ask me, or ask the question in the group also, and I'll be sending PPT in PDF format. Some of you are asking some questions regarding previous topic also. I have answered it to you. So in that PDF, whatever notes would be given, please copy it down in your science book. I'll be checking it and will be giving you internal marks for that. Please be serious and start doing your assignment properly. Thank you.